over the next 2 weeks, you're going to see that essentially everything we've done so far in this class has a rotational equivalent. We can turn all the equations we've learned into rotational versions of those equations. So the first thing we learned in this class was kinematics. I'll show you now how to turn linear kinematics into rotational kinematics. And later on, we'll learn how to turn Newton's second law into rotational Newton's second law, energy into rotational energy, momentum into rotational momentum, or angular momentum. And for the most part, it's pretty straightforward to do this. We're just going to replace our linear quantities with the rotational quantities that we just defined. So here are 4 kinematic equations that you've seen many times. And I'm going to turn each of these equations into the rotational version by replacing quantities with their rotational counterpart. So velocity becomes angular velocity. Acceleration becomes angular acceleration. Our first kinematic equation now looks like omega final equals omega initial plus alpha t. The rotational equivalent of position is angular position, theta. So our second equation looks like this. Theta final equals theta initial plus 1/2 omega initial plus omega final t. And I think you can see where this is heading now. Third kinematic equation. And fourth one. Okay, works kind of like magic. So in the next video, we'll do an example problem using our new rotational kinematic equations.